Hello everyone, welcome to this video. In this video, we're going to talk about multiplication algorithm in signed magnitude representation. So basically the multiplication of two fixed point binary number in signed magnitude representation is done with the process of successive shift and add operation. So we'll be following this flowchart and then doing some examples here. First of all, we'll take a very simple example. We'll try to multiply the number 2 into 5 and then basically get the answer 10 here. So what we need to do is we need to divide these two numbers in two different representations. So if we represent the number 2 as b and then we take it into a 4-bit representation of binary numbers, this is basically 0010. bs will be 0 since the value is positive. We'll take q as 5. The 4-bit representation is going to be 0101 and then the qs is going to be 0. So basically the multiplicand is in b, which is the value 2, and multiplier is in q, which is the value 5. So what do we do first? We first figure out the sign or the resultant sign that we'll get. So basically as will be bs xor qs. So if we have 0 and 0, the output is going to be 0. So the resultant sign of this particular multiplication operation is going to be a positive sign. Now we'll talk about the result and then we'll perform a result. Now based on this flowchart, what we need to do is make a at 0, e at 0, and then step counter as number of bits in q. So we'll represent this in table form. First of all, we'll write b, which is 0010. We'll save it as it is here. Then we'll have a bit e, which will be 0. We'll also have an a, which will be represented in 0, but we need to keep the number of bits similar to that of b and q. So a will be 0000. We'll also have a q where the bits are basically 0101. We'll try to check qn here. Qn would refer to this particular least significant bit here. So in this case qn is 1. We'll also take a step counter. Step counter is the number of bits in q. So basically since the number of bits in q is 4, so we'll represent 4 here and then we'll represent our actions. So first of all, what we're going to do is we're going to check the value of qn. If the value of qn is 1 or 0, so basically since the value of qn is 1, we are going to do ea equal to a plus b. So what we'll be doing here is ea equal to a plus b first, which means we should add b to a. So 0010 will be added here. 0010. We'll keep e as it is and then q as it is, because in the next operation we have to shift right eaq. So shift right eaq. So if we right shift this eaq value, we'll get 0 0 0. This particular 0 will be shifted here, 1 will be shifted here, 0 will be shifted here, 0 will be shifted here, 1 will be shifted here, and then we'll get a 0 here. So this will be our first iteration and our step counter will be decreased by 1, which means step counter is 3. Now we'll check if our step counter is 0 or not. If it's not 0, then we move to checking the value of qn again. In this case the qn value is 0. So what we should be doing is we should just shift right eaq here. So we're going to do shift right e, a, and q. So if we shift right eaq here, the result is going to be 0 0 0 0 0 1 0 0 1, and then the step counter is going to be decreased by 2. Since the step counter is still not 0 and then we have still not reached the end, we'll again go back to checking the value of qn here. Now since the value of qn is 1, what we need to do is we first need to add ea equal to a plus b. So ea equal to a plus b, which means we're going to add b to this particular value here. So 0 0 1 and 0. Let's add this 0 1 0 0 E will be as it is, and then Q will also be as it is. Now we need to shift right EAQ, shift right EAQ. So we'll do 0 0 0 0 1. This 0 will come here, this one will come here, and then 0 0. Now the step counter has decreased to 1. Again, since the step counter is not 0, so we'll again check our Qn value. This is 0, so we again need to perform shift right one final time. So shift right EAQ. So if we shift this right, so 0 0 0 0 0 1 0 1 0, and then the step counter is going to be 0. So once the step counter is 0, we go to the end of our operation. Now the multiplication result will be the value of AQ. So if we compare the result, this will be the value of AQ combined. So if we consider AQ, this is our AQ value here, which means 0 0 0 0 1 0 1 0, and then a 1 and 0 here. So if we convert this into our decimal number, 12488 plus 2 is 10, as we have already determined that our result will be a positive 10. So this is how the multiplication of two signed magnitudes data are done. I hope the concept is clear to you. If you have any problem understanding the process I did here, please comment down below and I'll try to help you out. So I'll see you in the next video. Bye bye.